Let us begin. This is going to be, so really, I'm going to give a little bit of sort of past history, right? And part of the goal of this talk is going to be to rationalize, in both senses of the word rationalize, the different stuff that I've done to try to find an intellectual through line to all of this stuff. Because I started out at UPenn, at the Institute for Research in Cognitive Science, which really had a very balanced, I was lucky enough to have a balance between sort of the cognitive science side and the NLP applications side of things. And then I came here to Maryland, and I went through a long period when I was really much more focused on the application side, right? I was working on machine translation, I was working on information retrieval, I was working on core problems in NLP like word sense ambiguity and so forth. And in the past 5 or 10 years, I've kind of been coming home. Hi everybody, I'm home. But you have this sort of collection of different stuff. This is just kind of a sampling up there. You're not supposed to read it just to get an impressionistic view of stuff that I've been doing, trying to figure out kind of how it all fits together. And so it's a little bit ambitious, and I don't know if I will succeed at all or any of the parts, but the talk is intended to be partly autobiographical, partly research presentation of stuff, partly programmatic, and as you'll see toward the end, also partly kind of evangelical, like here's a way of thinking about it, and I would love you to think about things in this way also. Right? So let's go way back to before when a bunch of you were born, and one of my early papers was on left corner parsing and psychological plausibility, where the core issue at the time was, is human parsing bottom up, is it top down? And it turned out, and I was really basically kind of wrapping up with a bow stuff that had already been started by other people, Abney and Johnson, Philip Johnson Laird. It was very closely related to Mark Steedman's stuff. But this idea was that if you look at something as straightforward, seemingly, as people's load on different structures, people have the property that they're fine with lots of left branching, they're fine with lots of right branching, and they're terrible at center embedding. And neither top-down nor bottom-up parsing gives you that behavior. That's the problem, right? And so what I basically helped put a period at the end of the sentence for ideas that had already been developing was the idea of left corner parsing, which is a combination of bottom-up and top-down processing, right? So you recognize the quote-unquote left corner of a constituent, you then know that you've got potentially that constituent, and then you predict the rest of it top-down, right? So you see a determiner, I might have a noun phrase. You've got a noun phrase, I might have a sentence. It could be this structure, right? Crucially, as part of this process, you build the larger structure by integrating the bottom-up piece, which was constructed this same left corner way, right? But ultimately, once you've succeeded in completing something, you integrate the two. So you kind of have this top-down view, right? The thing that you were predicting. You have this bottom-up view, this thing that you've built, and you basically say, these two are the same thing. And if this reminds you a little bit of tree adjoining grammar, my advisor was Aravind Joshi, so you have sort of your top-down view and your bottom-up view of a constituent. In that sort of adjoining thing. So crucially, what we have here is integrating top-down prediction with bottom-up evidence rapidly, because it turns out if you want this to work, you need to be eager about doing that attachment when you can, otherwise the right branching facts don't work, right? Okay, so that was some early work. In my dissertation, I looked at a semantic phenomenon that you all probably think of as selection restrictions or selectional preferences. Now, at the time, the dominant theory was, the cats and fodder are, plus or minus edible for the object of eat, right? It was this very strict, you either fit or you don't. But this didn't match the facts, which are there are graded judgments, right? So, Mary drank the sand is not selectionally fantastic, but it's a hell of a lot better than Mary drank the table, right? Or Mary drank sincerity or responsibility or something, right? And so what I did at the time, right, was because this new statistical NLP stuff was happening, let's be data-driven, right? Was I began with the idea of point-wise mutual information, which is an association score, which is hidden on the inside here as the log of that ratio there. But I used that to develop a measurement, if you will, of a verb's selectional preference strength, right? And what the verb selectional preference strength is it turns out to be the Kale divergence, the difference in the probability distributions, between what you would expect the semantic class of the argument to be if you didn't know what the verb was, right? Just think of it as an average across all verbs, I have no idea, versus the conditional probability distribution of those semantic classes, given that you do know what the verb does. And so you can interpret this as saying that the strength of a verb's selectional preference is literally, because this is measured in bits, is literally the quantity of information measured in bits that a verb carries about that argument, right? That potentially has an interesting bearing on some of the things like in earlier talks we saw where you have effort in the brain and what's happening at which word, because you actually have to remember that some of the information for that word doesn't live when you, isn't just there when you see that word. It's there before you see the word, right? And so this was kind of one of the core dissertation things that I did back then. And by the way, this does allow you to get those graded effects, right? Essentially, if you take a particular class, one of the C's inside that sum up at the top, and look at its contribution to this sum, that measure turns out to be a pretty decent measure of the semantic fit, and it is a quantity, not a yes or no, it fits or it doesn't. Right? Okay. So here's sort of the today update of that thinking. If you go look at this measurement, this Kale divergence, people weren't using the term at the time, but this is actually Bayesian surprise. Right? This is actually the difference between the prior and posterior distribution, right? And if you do a little of do the math, what you find out is that this measurement really is an expected value, right? An expectation of the difference you're going to get in surprisal, right? Based on the verb, when you're talking about the surprisal of the particular argument that you're going to get. And that's pretty cool. So the takeaway for this bit, I had no idea at the time, or much later, or really until I was putting this talk together, that there is a unified way of looking at this, right? That is about top-down prediction, bottom-up evidence, and an integration process, and the way that I did that stuff back then turns out to align very well with thinking of this in a Bayesian framework. Right? And when we talk about prediction, by the way, I would commend you to the Cooperberg and Jaeger paper on kind of what is prediction, where they talk about Bayesian surprise and lots of other things as well. Okay, so now let's fast forward. Cute little calendar up there. We're going to fast forward many years to like now. And in fact, now like here within the last couple of days, what you've seen is that surprisal theory, which is a Marr computation level theory, right? It's not making mechanistic claims about the cognitive operations, but that body of theory is actually starting to move in the mechanistic direction, right? We've seen cool talks here that look at the idea of actually storing and retrieving things in a lossy way, right, in the lossy context surprisal. We've seen stuff where recency and sort of decay of stuff in memory is being modeled in some way or another, where there are theories about sampling as a mechanism for looking at alternative possible next things on the basis of what you've seen before. What colleagues and I have been doing, specifically Chibuka Ohams and Safik Nair and Shohini Bhattacharya, has been looking at this from the opposite direction. Moving toward the mechanism, starting with the thinking from the implementation side, the neural implementation. Predictive coding, which is grounded in computation level theory also. Go look at Friston, the free energy principle, that stuff. There's a great paper by Sam Gershman, a short paper that brings these things together, right? But the predictive coding framework, there's a bunch of neuroscientific evidence that this architecture, which I'll tell you about in a second, is neurocognitively plausible, right? So what is predictive coding? Predictive coding is essentially a theory that says that instead of just processing stuff bottom up, at every point in time we are constantly making top-down predictions, bringing those into contact, right, with the evidence. So the top-down is like a Bayesian prior. You bring that into contact with evidence. If it matches perfectly, you're in business, you actually don't transmit anything further. which is great, very energy efficient, right? If you make good predictions, you don't need activity. That's good for brains, I would presume, right? Otherwise, what you propagate back upwards is the error signal. It's what you got wrong so that you can then modify your model at that next higher layer, right? So this goes way back, but the paper most often cited as sort of an origin is the Rao and Ballard, where they did this for vision, right? I want to give you an example that helps explain why I am so excited about the concept of predictive coding. Presumably, many of you have seen Colonel Sanders from Kentucky Fried Chicken before. At some point, apparently, some little girl on the internet asked the following question: "Daddy, why is his body so small?" And now you can't unsee it. I mean, literally, you can't unsee it. I have ruined this image for you for the rest of your life. You will never see the image in this way. Now, let's see if the audio sample works. I've got an audio example. I've never done this before. Let's try. No, it's not letting me click. Go look up sine wave speech, and you will find some really interesting examples where you hear something that sounds like, right? Then if you know what it says and listen to exactly the same acoustics, you actually perceive what is being said differently, and you can actually understand it. It's an auditory example of precisely the same Colonel Sanders phenomenon here, right? What does this tell us? What this tells us is that it's strictly bottom-up is not the right model, right? These examples and a whole body of evidence, I'm not saying this is the entirety of how the brain works, but there's a lot there, and oh, by the way, the entire AI community pays zero attention to this whatsoever, right? We're just throwing more and more money into these sort of feed-forward kinds of models. In terms of kind of neuroevidence for this, there's a paper that was led by Christian Brodbeck and lots of other collaborators here at Maryland that I was lucky enough to be a co-author on, where there's actually using an MEG study providing evidence for this top-down influence at low levels, as in at the level you're predicting phonemes, you are in fact being influenced by sentence-level context, right? There's an interesting problem, though. Virtually nobody seems to be doing predictive coding with language, with very few exceptions, right? What you have, this Rao and Ballard thing, is not in time. You don't have language, you have sequence. We have this incremental interpretation thing going on, and you tend not to see that. So that's what we tackled. And we built on a model introduced by Baron Millage, who is one of the few people who's really bridging between the neuro kinds of models and the deep learning kinds of models. And if that picture on the top right looks to you like a hidden Markov model structure or an RNN, that's not a mistake, right? What you have here is effectively a mashup with what I would argue are the best features of HMMs and RNNs, right? And predictive coding models kind of all put together, right? And so the way that this works basically is you have your temporal sequence, and at any given point, on the left here, I've highlighted the previous state, the current state, and the prediction, just like in HMM, right? A transition and an emission, right? And if you model, if you look at what's going on there, what happens is that the state, which is no longer an HMM-style state, it's a vector in a space, right? So these are continuously valued, like in an RNN, right? You have an initial prediction based on the context, and you have evidence from what you've observed, and then there is this iterative, call it a kind of a settling process, a converging kind of process, where your initial prediction of the representation for your hidden state, like in the hidden state of an RNN or an HMM, right, moves from what you predicted, now that you've got new evidence, that's your prior, to a posterior location, and at the same time, that emission, that thing that you predicted, is also moving from some representation of what you would have predicted without seeing anything, to an adjusted representation that is now informed both by the top-down and by the bottom-up. Now, one of the really cool things about this is that as a mechanistic model, it enables us to instrument it, right? We can actually say, if we are thinking of this as an honest-to-God cognitive process, what can we measure here and relate via linking theories to things we think are actually happening in people's heads, right? And so to give you a flavor of this, right, in sort of classic, I drank coffee with cream and, right, if you're making a good prediction, right, so your blue distribution here is close to your prior distribution, your top-down is actually mostly on the mark, then your representation of that internal state is not going to have to go very far to get where it winds up, and your representation of what you're predicting, the word itself, is also not going to have to go very far to wind up where it winds up. On the other hand, you know, if we're talking about salt, not sugar, right, now you have further to go to reconcile your prediction, your prior to get updated into the posterior is requiring more to get there. And this model has a very precise way of characterizing in a mechanistic, process-oriented way what it means to, quote unquote, get there and the process of getting there. And so what that means is that we can reach into the model and measure things, right, that we think might be relevant in the cognitive process. Things like in the top row of this table, how many iterations of this settling process, how much time does it take before you decide on what your new representation is? Well, now we can talk about time, right? We measure time when people are doing things like reading times. You can measure things like how far did it have to travel, which corresponds to possibly the idea of how much does the internal representation need to change from its initial to its final representation, and so forth. And there's this nice paper by Resnik and Newland about prediction, which includes predictive coding, that we've drawn on to try to characterize different ways of linking measurements in this model to things that people are talking about when they're talking about prediction in cognitive work, in psycholinguistics and in neurolinguistics. So I won't go through the entire thing. There's a paper that is in Revise and Resubmit, hopefully almost there. Here's one of the core results from the paper. What we get out of this, right, are predictors, just like surprisal is a predictor of cognitive effort, say, right? Surprisal predicting reading times, same paradigm, identical paradigm, right? We're using the delta log likelihood, which is basically a measure of how well is this predictor, how much is it contributing to our prediction of the reading time over and above, that's the delta part, stuff like, you know, frequency and word length, that sort of thing, right? And a couple of important things to note here. One is that if you have surprisal baselines, we're in the right ballpark here. That's a validation that this is doing stuff. It's predicting as well, or if you look in the table on the right, sometimes better, some of these predictors, than straight up surprisal, right? So this is the beginning. This is really just an initial point where now that we have a model, now it opens the door to all sorts of different things, to different linking theories, to exploring different contributions. We use naturalistic listening, but you could do trial-based experimentation in order to probe specific aspects and so forth, right? So what we have is a truly mechanistic, and by truly I'm emphasizing, right, there are claims, right? When you say, what are you claiming about your model? And what is just, like if you're using a large language model, what aspects, I asked this question the other day, what aspects of the large language model are you actually claiming are part of your story, and which are just like, well, this is how a large language model works and it's a tool to get there, right? We now can actually answer that question and say, yes, these aspects of the model are things that we are making mechanistic cognitive claims about, right? And it's grounded, as I said, in implementation level theory, and it seems to have been validated with some of this, this experimental work that we've done so far. Now, one of the things I'm excited about is future work. We only did this at one level, right? But you could imagine hierarchical predictive coding, which is what most predictive coding models are, a la Rao and Ballard. And as it turns out, Samer Nuruddin, who unfortunately had to leave, he's not here today, has a lovely hierarchical predictive coding model, and one of the only predictive coding models for language at all. Like I said, this hasn't been done very much. And so we're talking about collaborating and basically putting these two things together. So you have the temporal aspect and you also have the hierarchical aspect together in the same model. Now, in this last part, right, so the theme here that we're talking about has to do with relating the psycholinguistic stuff to the rest of the world, right? Autobiographically, what I can tell you is that I have moved personally into social science broadly as an application area for NLP. And what I want to try to do in this last bit is to connect stuff that I've been doing to stuff that we've been talking about. Okay, so let's start with the mental health stuff. So as it happens, I'm married to a clinical psychologist, so not a huge surprise that that might be an area that I gravitated toward too. The glass of wine is there. This is one of her slides, actually. She does prettier slides than I do. We actually, on a date night, literally a date night, came up with the idea for this workshop that's now been running at the ACL conferences for the last 10 years that brings together NLP people with people in the trenches in clinical research and clinical psychology. And an important point about this that's worth taking 10 seconds to emphasize is it really is for both communities. We designed things in the review criteria. It says we don't care how good this technical paper is. If one of the clinical people can't read it and understand it, it's getting rejected. And we do. We have. And we have a discussant structure where the technical talks will have a psychology discussant, right, there to ask questions and present reactions and stuff. So I like that structure. I stole that from a political science conference that I went to. Now, what things does that community do? It's NLP. It's not generally cognitive science, right? Just as an example of stuff that I've been working on recently, I've been working on the problem of identifying from somebody's language whether or not they are in suicidal crisis, which is distinct from being at suicide risk, right? Which is distinct from being at long-term suicide risk. And so I won't go into the details here, but what you can see here, each of these red and blue bars, is opposed to this peer support forum on Reddit where people are talking about possibly being suicidal. And the blue bars are the ones where experts have judged, yes, this person is literally in crisis. Immediate intervention would be needed. Unfortunately, all after the fact, right? This is something we're doing with retrospective data, although I am working with people on trying to find ways to deploy this stuff because I think we're getting close. And what you can see here in the picture is it's doing a pretty decent job of moving the blue bars up toward, I call those needles, up to the top of the haystack. If you are resource limited, as all mental health in this country is resource limited, and you can't see everybody who needs help, then you damn well want a good ranking to figure out who should be higher in this list, or at least who you're more confident that they need help in order to review it. And that informs clinicians a lot more than a label, a yes, no, right? And so that's an example of the NLP applied work. Now I want to give you an example of where I think things can fit in between the stuff I've been talking about and things people are caring about in mental health. And this is pretty cool stuff. So this is a ChatGPT generated image, right? And you're looking at a pretty normal image. Now, you might notice, but you probably haven't, that there's a little bit of a shadow on this guy's shoulder that if you stare at it closely, might look a little bit like a tarantula. Now, you didn't see that. Just like you didn't see the little body on Colonel Sanders, right? But there's a theory of predictive coding in psychosis, and there is evidence from other kinds of studies that one of the elements in psychosis that's going on is a misbalance between how heavily you weight the top-down evidence versus the bottom-up evidence. If you're doing this predictive coding, compute the prior as an adjustment of your model, you might be overweighing at the perceptual level, right? The bottom up. In other words, you're in a room, you know that in that context a tarantula wouldn't be on a guy's shoulder, but if that top-down prior hypothesis is not, right, is coming into contact with the bottom stuff and not affecting, then your error signal is going to say, kind of consistent with a tarantula on the guy's shoulder. And of course, then you do your model update, you do your belief update, right? Your prior becomes your posterior becomes your new prior, and so now you look at the bottom-up evidence again, if you happen to be schizophrenic. And now you've got top-down prediction that is more consistent with a tarantula, right? And so now you're more likely to perceive it as a tarantula in the same way that now that you knew you had body as a prediction, you were more likely to perceive it as a body under Colonel Sanders, and so it goes on until you have a hallucination that there's a tarantula on the guy's shoulder, right? Now, it turns out people have been exploring these kinds of predictive coding models for a lot of conditions. right? People have been exploring this not only for psychosis, but in terms of mood disorders like depression, autism spectrum, dementia, and so forth, right? But not language. There's very little that I've been able to find, because there's very little on predictive coding models involving language in the first place, right? Now, one thing that I did find that I think is fascinating is this very interesting paper where they were using music. They were using an oddball paradigm. So to what extent are you surprised by the next note, right? And if you look at that picture inside the red box, it actually looks a lot like the temporal predictive coding model. You've got hierarchy, and then you've got this temporal sequence going. And it turns out that you can take measurements from that model from people in an experiment. And you can use those measurements in a process that then leads to an analysis that distinguishes healthy controls from people at high risk of psychosis from people already showing early symptoms of schizophrenia. So I want to speculate that one could do similar modeling, but with linguistic prediction. I think there's a lot of stuff that one could do with these kinds of models. And so that's a potential connection, this predictive coding idea and the processing of language. There's been lots of work on the processing of language in different disorders. I mean, people study aphasia, people study dementia, people study schizophrenia, and so forth. But this predictive element adds a new dimension that people have started to explore outside the linguistic domain that I think we may now be ready to explore inside the linguistic domain. That's a little bit of the evangelism. Finally, I do want to connect this to another aspect of social science that I'm involved in, which has been in political communication. Actually, I got started in the mental health stuff partly because I was doing computational modeling in the political domain. We're working with Jordan Boyd Graeber, who is one of the great gurus of Bayesian topic modeling, and from him I learned to drink the Bayesian Kool-Aid. And we were looking at this, and I realized a lot of this stuff could potentially be applied in mental health as well. So there's a concept in political science called framing, political communication, which in general is about emphasizing certain aspects of things and de-emphasizing other aspects of things as part of getting your message across or convincing people what you want to convince them of. Literal framing happens. So this is a picture of the statue of Saddam Hussein being torn down after the US invasion of Iraq. This is the actual picture from a longer view. So that original picture is portraying it as a grassroots mob of people tearing down the statue. That's framing. Literally framing, right? What you see here is that this is actually a staged event. There are US military vehicles around the outside of this thing, and there's also, not a huge crowd, right? So that's an example of framing in a literal, intuitive way. Framing also happens all the time in other contexts. This on the right is my son Jay, who is a high schooler now. It's an old slide. When Reagan said mistakes were made, or when Jay, when he was little, said my toy broke, we have a passive construction, we have an inchoative construction, right? What are both of those syntactic constructions doing? This relates to some of the previous talks we've heard this morning, right? They are serving to emphasize and de-emphasize certain aspects of the event. Right? If you use a passive, you are de-emphasizing causation, you are de-emphasizing volition, right? You are merely focusing on the effect. The toy just broke. It broke. I don't know how it broke, right? And I will mention that Penn and Teller, the magician duo, Teller of Penn and Teller has literally worked with neuroscientists. Why? Because magicians know, right, intuitively a lot of neuroscience. And I would argue that so do politicians and little kids. Okay. So you see this, I'm going to go through this quickly because I'm running out of time, but you see this in the real world, right? So Breitbart is a far-right source of information, MSNBC is a far-left source of information, and they are expressing the same event, framing the event in different ways, and it is not difficult from reading it to see exactly the same thing happening. By the way, this notion of framing, which I call syntactic framing, has not been looked at. Again, people looking at outside of linguistics are not using the same linguistics concepts we are. There are opportunities here, right, for people to look at stuff. So here's going to be the final point. As a computer scientist, we often think about sort of a pipeline, right? You have information and you have expression of that information and you represent it somehow and you put it in your knowledge base and then you use it for stuff, right? And what I want to emphasize is that's not how the world works in terms of what's actually happening with people. That's what I want to argue here. What we've been showing here, right, is that we work with interpretations of the world. Not the literal Colonel Sanders, your interpretation of Colonel Sanders, which includes both the bottom-up evidence, but the priors you are bringing to the table, right? The big red arrow here. And this is really important. Here's a really interesting example. Dallas Card and colleagues looked at 140 years of discourse about immigration. And one of the things that they did, which is fascinating, is they took large language models and they said, let's look for places where large language models predict things that are metaphorically used to describe immigrants, right? Like animal, vermin, disease, cargo, right? Let's look for places where a term referring to a human being is in a context that has high probability of the terms in those categories, right? So the herding of these blank into stockades is pictured. That's a place where the large language model is predicting animal, but that was not the word. That was actually a sentence describing a human being or a set of human beings, right? And the reason that this is important, the reason this is so important, is that the priors influence our interpretation. Again, the big red arrow going in that direction from our priors to the interpretation. So if you see something like a kid knocking on a door and you say, what is their intent, right? If you are in a context where you have now modified your model, right, such that the top-down predictions for a person in a particular category are more strongly associated with a set of things that might be negative, you are more likely to have that be a negative interpretation, right? And so what we need to think about in terms of the takeaways, and this is the historical stuff, this is now my attempted rationalization, right? What I've been doing all along is prediction all the way down, right? What you have is Bayesian angle on integration of top-down prediction and bottom-up evidence. And now work on this temporal predictive coding as a mechanistic way of articulating how that might be happening as we do human language. And finally, potential connections between that predictive coding concept and the influence of the priors, both in the mental health space and the political communication space, and I would argue any space in which human interpretation is taking place, which is every space. Thanks.
Hi, Phil. Yeah, great talk, obviously. Super interested. I just want to hear your thoughts on that sentiment about these, especially these hierarchical predictive coding models and them not being used in psycholinguistics or like neurolinguistics, and how that might be because of some difficulties around the representations that should be used and these open questions about, especially at these increasingly abstract levels of the hierarchy, and just your thoughts on that.
Well, I mean, look, science has a sociology, right? This particular work has origins and roots in things other than language, right? And you also have to realize, I like to listen to the podcast Brain Inspired, which is a wonderful kind of combination of neuroscience, and there's some AI stuff thrown in there or whatever. One of the things you get when you listen to some of the guests there is this deep antipathy of, within neuroscience, there are different factions, right? Something that a lot of neuroscience distinct factions who disagree with each other agree on is they don't like linguistics. They don't like Chomsky. And I can understand that, right? But I think there's a major sociological piece to it. I also think there's a lot of looking under the lamppost for the keys, because we deal with what we know how to deal with. And that's one of the reasons we need more interdisciplinary conversations to take place. That would be my take. Yeah.
Hi, Phil. That was great. Mary Ellen McDonald. I wanted to ask you about the predictive coding in the clinical cases, that is the suicidality and depression and all of that. And because there is another field outside of language and NLP where people try to do this using language, often published in social psychology journals, perhaps most associated with Jamie Pennebaker, in which they count the words. And they count people with depression have more pronouns of certain sorts and more thinking-based words and so forth. And so this is a really, on the one hand, very interesting and in some cases very successful predicting of certain mental states by language. And on the other hand, it's what you might do if you know nothing about psycholinguistics or NLP. And so I'm wondering how what you're doing is comparing to their word selection models.
So thank you so much. Thanks so much for the question. Yeah, I've literally had this conversation with Jamie. Right? He would be one of the first people to tell you that what he's doing does not involve a deep theory from the linguistic perspective, right? What you're doing is the other thing that's really important to notice, and this may be unfair, so if people want to push back on it, it's okay. But my observation is that you have a zillion papers where the linguistic inquiry and word count is being used, and what you have are lots and lots and lots of statistically significant effects with very small effect sizes. And so I think there's a lot there, right? The place that I guess I would try to bridge those things is in the notion of representation, right? So the Pennebaker work is a very flat notion with categories. You have words that are first person, you have words that are anger words, you have words that are, cognition words like think and believe. Right? I think in order to integrate that thinking, where I definitely think there is value, I mean, they've shown important connections with various things. What we need to do is manage to bring those concepts together with a computationally better articulated notion of representation. Right? To say it's an anger word, right, is a very, very blunt instrument. To simply count things is a very, very blunt instrument, right? So we have computationally more sophisticated techniques. On the other hand, I'm a huge believer in not throwing the baby out with the bathwater. I am not and have not and would not be suggesting, oh yeah, we're gonna let embeddings do all the work, right? There needs to be a place for the knowledge that we've acquired through these other things to feed into those models. And so I think that's the kind of tack that I would take. There's value there, but we need to get beyond counting. We need to figure out what we've learned from these things and incorporate them into our models.
Hi, Thomas Clark, MIT. Thank you so much for the talk. Consider me evangelized. I'm very interested in applying these types of predictive coding models to online sentence processing. One thing I was wondering if you could elaborate on is sort of what happens when prediction fails for various reasons. And you could imagine sort of different cases, one being maybe memory constraints. So in garden pathing, we simply can't keep track of the different alternatives, even if they're possible or have some probability. Yeah. Another case might be when there are errors or mistakes, is there a difference between two equally unpredictable words, but one is more easily explained as an error in some kind of noisy channel type model. You mentioned like a settling process of taking some word and then somehow trying to integrate it when you fail to predict. I was wondering if you could just elaborate a bit more on how these types of algorithmic level accounts might handle cases where prediction fails and what that might tell us about online sentence.
I think that I would say that prediction fails is a little bit of a category error in this context. Right? Prediction doesn't, I mean, a piece to the whole garden path phenomenon, of course, right? So what we have, but in general, these models are essentially making the claim that we are talking in probability distributions. We have a probability, it is very constrained or it is very not constrained, right? And so predictions, it's less about prediction failure in many cases than it is about the indexing the effort in order to integrate the information because your prediction was bad. You're getting lots of error signal and then what happens? In terms of things like the garden path phenomena, locality dependency stuff, all of this wonderful stuff that people have been exploring with surprisal, I guess what I would say is, here you go. Here's a new tool, and unlike surprisal, it's a mechanistic model, right? So you can be clear about what you're claiming about it and not. And what would be really wonderful is you now have, a generation of work where people have been using surprisal, and I think we all agree, minus log, the probability of a word given context is overly simplistic. That's what I'm seeing here and in the community over the last couple of years. We're moving away from those simplistic things. And so this is just everything that you would apply in that slide where I said we're moving from computational toward algorithmic and mechanistic using these other things. Everything you're doing there, I would argue, including the garden path phenomena, right? And doing more sophisticated representations of memory, doing all of that stuff, you have exactly the same opportunity in terms of both the phenomena and in terms of the kinds of mechanisms that you might want to explore. So this is really just approaching the same goal from two different pictures. This is a new way of saying, here's a new tool that lets us approach it from the already mechanistic direction, as opposed to the computational direction.
Thanks.
Thank you.
Hi, very exciting talk. I'm Hailing Hao from USC. So I'm very intrigued about the talk, especially the part about using insights from language and psycholinguistics to clinical and political settings. But my first question is, how do you propose that we interfere? So language and those insights are so powerful, like for the Capitol riots that happened like in the last election cycle, people actually found that using Twitter data and just basically tweets, you can actually predict when that Capitol riot is going to happen, but it still happened anyway. So, I mean, when we have those type of insights, like how can we actually use those insights to interfere like in both clinical and also political settings? And the second point is, I mean, as these tools become more and more powerful and we were implementing new things, making these more like predictive, improving predict accuracy and stuff. Private companies are also doing those type of stuff, like Cambridge Analytica. They're trying to use people's data, like their language production on the social media, trying to predict election outcomes and potentially interfere with elections in both the UK and the US. Like, how do we, when we're developing these type of insights and even technologies, how do you keep those things in mind that they're not going to be used to actually harm society? And like, what's...
This is, okay, so you've raised a bunch of different issues here. I actually spent a summer working for Bob Mercer, who was the guy who funded Cambridge Analytica back in the day. Yeah. Whew. Yeah, preview of the future. Anyway, so the thing that I want to focus in on two aspects of your question. One is you're developing new things. How do you make sure they're used in the right way? Yep. And the answer is knowledge, right? I promised myself that I was, even if I was going to take DARPA funding, I was never going to work on missile targeting systems, right? I was going to work on things that had dual use where maybe they wanted it for that. Not missile targeting, thankfully, but there are many uses, right? This is not a question for the research community. In my opinion. We do not have control over this, as you saw, right? OpenAI put this stuff out. DeepSeek has now put stuff out, right? Where you actually have access to the weights in the models, and now you have people who are using large language models and they can do the same kind of protein folding and all these other sorts of things for all sorts of other purposes, right? So I don't think we are going to be able to control that ourselves, and unfortunately, I think that the likelihood of external controls taking place is really fairly low. By the way, a little plug, I have a paper in press, it's on arXiv, called Large Language Models Are Biased Because They Are Large Language Models, which is about harmful bias, where I'm kind of making some of this argument that the power is so concentrated that we're not going to have a lot of effect on it. Now, in terms of what we can do from the cognitive perspective, right, there's a wonderful piece of work by Lisa Feldman Barrett, who has a theory of emotion that is grounded in predictive coding. And she has a wonderful piece of writing called When a Gun is Not a Gun. Mm-hmm. And it describes a scenario, right, where a police officer's priors lead the police officer, this is a hypothetical but very realistic scenario, lead the police officer to when they stop a kid, the kid is pulling out a cell phone, they see a gun, and they shoot the kid, okay? And her argument, which I think is very compelling, is the police officer did not decide to shoot somebody with a cell phone. The police officer shot somebody with a gun, as far as their perceptions were. They literally perceived a gun, the same way you perceived that body. And in that work, she emphasizes that one of the only ways to intervene in this is to affect the priors. Right? It's a battle over the priors. So if we want to influence things, we need to help, and we need to, flood the zone, right, with the kinds of messages and the kinds of associations that we want to be positive. And this happened in the past. There are things that were socially non-normative, right? Couples of various kinds you would never have seen in a TV commercial together, right? Whether it's gender, whether it's race. And what happened? You had exposure through sitcoms and television shows, right? And that exposure helped to change people's, in my opinion, people's priors, right? And so I think that's, to the extent that we can do anything, bridging the research, what we're learning from the research, to trying to affect society, there are really two things. Number one, do good research. Do things that are really solid, that can stand up to scrutiny, be clear on what the research questions are, right? And why it matters from an intellectual perspective. And then try to connect it, right, to what's going on there out in the world. Because a big piece of what we're doing is messaging, the same as anybody else. What we are trying to do is message the importance of the science and the value of the science, as well as this other level of trying to affect what's in people's internal models, so that their interpretations, when they bring them to the world, right, have countervailing forces to, there's a whole space of things. Never mind the value judgments, right? Let's just talk about there being a range of things that go into people's priors, right? That's different from the range of things that we're giving them now.
Very insightful. Thank you.